All right, today's lesson is lesson 6.2. In today's lesson, we're going to be finding the inverses of a function or relation and determining whether two functions or relations are inverses of each other. You see this is past skill 2, 1E, find and graph the inverses of functions if they exist. All right, first of all, what is an inverse function or relation? An inverse is basically where the domain becomes the range and the range becomes the domain. In other words, the x becomes the y and the y becomes the x. Here we've got an example of two functions, or two relations rather, that are inverses of each other. Notice 1, 5, 5, 1, 2, 6, 6, 2, 3, 7, 7, 3. So when you're doing your first set of problems up here, all you got to do is take and switch the numbers. Alright, so the ordered pairs of the relations are the coordinates of the vertices of a rectangle. Find the inverse of this relation. Start off with the bracket, parenthesis, then we'll go through. 1, 3 becomes 3, 1. 6, 3 becomes 3, 6. 6, 0 becomes 0, 6. 1, 0 becomes 0, 1. That's all there is to that first set of problems on your worksheet today. All right, next we're going to be taking a look at inverse functions. All right, notice this symbol right here, the -1 power. That means that this function and this function are inverses. This is the inverse function. Now, one thing you can look at on a function to tell whether they're inverses is notice right here, let's say that we've got two functions. One is x minus 4 and the other is x plus 4. Well, you notice if we run a 6 through our first function, 6 minus 4 is 2. Take that 2 and run it through the second function. 2 plus 4 is 6. So since we put in a 6 and got out a 2, and put in a 2 and got out a 6, that means that these two functions are inverses of each other. All right. Now, when you're asked to graph, first of all, we've got to find the inverse of this function and then graph the inverse and its original function. So when you're asked to do this, what you need to do, first of all, just like we did before, we're going to take that f of x, which is actually y. So we're going to change the f of x to a y. And then, just like we did in the previous examples, where we swapped the x's and the y's, notice this x gave us a y, the y gave us an x. In this problem right here, the x and y switched places. That's what we're going to do with this one. We're going to turn this y into an x, and we're going to turn the x into a y. And I just noticed that I made a mistake with this one. Let's fix that up. Make it like it should be. That was supposed to be a plus 1. Okay. And now what we're going to do with this equation right here is we're going to go through and we're going to make sure that we get y all by itself on one side. All right, so step 1, let's subtract 1 from both sides. That's going to give us x minus 1, and that's going to get rid of the 1 over here. Now we need to eliminate the -1/2. The way you eliminate a -1/2 is multiply everything by a -2. All right, because -1/2 times -2 is a positive 1. That would give us just the y there, 1y. So multiplying by -2, that's going to be -2x, and -1 times a -2 is a positive 2, and that equals -1/2 y times a -2 is just y. Now, to represent this as a function, what I need to do is change the y into f inverse of x. So, f inverse of x, and I'm going to write this part right here, is equal to -2x plus 2. Now, that takes care of finding the inverses. Now we need to graph the function and its inverse. To graph these, just go back to what we've taught you before. Your y-intercept on the first one is 1. Your slope is -1/2. So down 1 over 2, down 1 over 2, down 1 over 2, and so on, until you get enough points where you can actually graph this thing. So I think that's enough points for us. Let's get that graphed right there. 1, 2, 1, 2, 1, 2. Perfect. And then go all the way to the ends. Complete your line with the arrows. And that's the original first graph. Now let's go ahead and graph the inverse. My y-intercept is positive 2, and my slope is negative 2. So down 2 over 1, down 2 over 1, down 2 over 1, down 2 over 1, up 2 over 1, up 2 over 1, up 2 over 1, up 2 over 1. Okay, so now we're ready to graph those. And that is the graph of the original function and its inverse. That should get you through the next 3 exercises on your assignment. Okay, the last thing that I want to cover in today's lesson is verifying inverses. You can determine whether two functions are inverses by finding both of their compositions. Now this is what we did in yesterday's lesson. If both compositions equal x, then the functions are inverses of each other. Direct your attention to the previous day's assignment. You'll notice that in this problem right here, I believe this was problem number 9, both of these were equal to x. That means that these two functions were inverses. Just to demonstrate, if I just think of some number, for example, in this problem right here, if x is 10, then 10 minus 6 is 4. Now, in this problem, if x is 4, 4 plus 6 is 10. Notice how the numbers just swap places on that. All right, so let's clear that out and get back to the lesson here. Okay, so how do we do this? All right, simple. We're going to do the composition of both of them. Let's do the composition first of f composition g, meaning that we're putting g into f. We're putting this one right here in place of that x right there. So what do I have? I've got 3/4. Instead of x, I'll put 4/3 x plus 8. And then I'll finish up with the rest of the problem to minus 6. All right, now we need to go ahead and distribute our 3/4. So 3/4 times 4/3 x is just x. And 3/4 times a positive 8. Remember my trick. 8 divided by 4 is 2. 2 times 3 is 6. That's going to be plus 6. And then I've still got my minus 6 there. X plus 6 minus 6 is x. Now, if I'd gotten anything other than x right here, that would mean they're not inverses. Okay? So since this is just x, that means I need to go over here now and check this one. Check the opposite direction on this. I'll do reverse composition. I'll do G composition F. Okay, so what does that mean? That means now what I'm going to be doing is taking this function and taking the x out and replacing it with this. Alright, so G composition F. That's going to be 4/3. Instead of x, put a 3/4 x minus 6. And then don't forget your plus 8 on the end. And now, just like we did previously with this example, let's distribute your 4/3. So 4/3 times 3/4 x is just x. 4/3 times negative 6. All right, negative 6 divided by 3 is negative 2. Negative 2 times 4 is negative 8. And then your plus 8. And so x minus 8 plus 8 is also x. So notice here, since we've got x here and x there, then these two are, yes, inverses. That's all for today's lesson. I hope you enjoyed it. See you tomorrow.